Hello, we are Group 6, and this is our Project 2 presentation on ethical disasters. So for this presentation, we're going to talk about 2 ethical disasters, and the criteria that we chose to use on how we choose our disasters is going to be first social impact. So we're going to discuss how it impacted society, not only then but now. The industrial impact, how did this disaster impact the regulations and rules that we are required as engineers and employers in the field to use as regulation? The relevance, when and how long ago did these disasters happen? And then today's impact, how do these disasters impact how we as engineers will complete our jobs and the regulations that are in place today?
For our first ethical disaster, we decided to do it over Apollo 13. Apollo 13 was to be the 3rd lunar landing attempt. However, on April 14th of 1970, the mission was aborted due to the blowout of a service module oxygen tank. Around the 50-hour mark after launch, an oxygen tank blew up, causing another module tank to also fail. After investigation, the problem was identified. The central module had undergone improvements prior to takeoff, but the thermostatic switches weren't updated along with the changes. This resulted in the tank being damaged after testing and overheating, causing the explosion when it was again filled with oxygen. The craft was approximately 200,000 miles away from Earth when the explosion happened. After the explosion, there were many survival issues, including power, water, and removal of carbon dioxide, but in the end, the crew was successfully rescued. Fortunately, there were no casualties, making it a successful failure. Additionally, engineers were able to learn some valuable insight from the incident according to our primary source, Apollo 13, Guidance, Navigation, and Control Challenges. As for some notable engineers that were involved, Arnold Aldridge was the engineer to read the reports from the astronauts and called John Aaron, another engineer, to discuss the issue. Aldo Bordano was another engineer called in around midnight that was later featured in multiple interviews. During that same time around midnight, there were about 200 different engineers called to the scene when the event took place. Henry Pohl oversaw the command module's thruster rockets, and Northrop Grumman was a company that played a major part in bringing the astronauts safely home.
Apollo 13 details. I'm going to be talking about the ethical and criminal issues and societal, economical, and political impacts, and talking about NSP codes that were involved. For ethical issues, there was a malfunction that involved an explosion and a ruptured oxygen tank. This led to no oxygen in less than 3 hours. Water and electrical power and the propulsion system was down. For criminal issues, there were no criminal charges involved. For social impact, Apollo 13 impacted the world by expanding space exploration. This led to new technology being made advanced to keep up with future exploration. For economical impact, with Apollo 13, the United States was able to create technology and manufacturing jobs. For political impact, the failure of Apollo 13 led to a mischief chance in politics. After the accident, 3 missions were dropped due to lack of funds. The support from Congress was weak, and the current president did not have interest. The NSP code that was involved with Apollo 13 would be under Professional Obligations number 1. It says, engineers shall acknowledge their errors and shall not distort or alter the facts. NASA ran many tests on the oxygen tanks with no issue until days before the mission, and it failed. They made no change and let the mission go without a failed test.
Our second ethical disaster is the collapse of the FIU bridge in 2018. According to the National Transportation Safety Board, in December 2015, Florida International University awarded a design and build contract for a pedestrian bridge to MCM, a construction management company based in Miami, who subcontracted the structural design of the project to FIG bridge designers. The final design of the bridge had a main span of 174 feet and was composed of a completely concrete design with upper and lower concrete decks, as well as an asymmetrical concrete truss design. The design of the bridge failed in the connection of 11 out of 12, where the 11th truss was connected to the main deck of the bridge. This connection was subjected to nearly double design loads when calculated after the disaster. This calculation failure is the main cause of the collapse.
Primary sources from the accident report done by the NTSB show that the cracks were 40 times larger than the accepted length of a crack in a reinforced concrete bridge. Workers were attempting to stop the cracking by tightening tension rods around the area when the bridge fell. This was a direct violation of Florida regulations that the construction workers simply did not see the danger of. This accident led to the death of 6 people, including 1 student from the Florida International University. Such a fatal disaster was blamed in the end on the NSPE on a lack of proper professional engineering supervision over the worksite. The construction company, MCM, had placed the university responsible for providing engineers who had none on faculty. The finger pointing and blaming on who should have caught the mistake led to the breaking of 2 specific rules in the NSP Code of Ethics. Firstly, Rule 2, Rules of Practice, Part 1, Part B. Engineers shall approve only those engineering documents that are in conformity with applicable standards. The plan for the bridge was reviewed by a handful of companies and firms, all of which overlooked the miscalculation. And Rule number 2, Part 3, Professional Obligations, Part 1, Part A. Engineers shall acknowledge their errors and shall not distort or alter the facts. There was a lot of finger blaming between the parties involved that caused a lot of confusion in the final reports.
So for our justification for this, Apollo 13, this demonstrates the importance of reporting and following through with each issue to ensure that there are no larger issues that can happen. The disaster is a simple reminder to engineers that even the smallest detail can cause an accident later and can be detrimental, even if something as simple as dropping an oxygen tank should be reported because it is very important. We did see societal and many different impacts from this due to the disaster, leading to loss of money and budget issues, as well as loss in trust with the company. For the FIU bridge, it is a simple reminder to engineers that it is not to be taken lightly. Everyone involved is responsible and there is no room for laziness or error. Proper qualifications is needed in order to ensure the safety of the community.